Land Before Time presents. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Goal. Return the number of distinct ways you can climb to the top. This question is pretty straightforward, so I only have one question. What is the range of n? 1 to 45. In most interviews, they'll probably give you the constraints on n. As we are practicing, it's still a good idea to ask the question in case they don't give you those constraints. Moving on to some examples. Let's go ahead and start with example 2, where n is equal to 3. I know that 3 can be made as follows. 1 plus 1 plus 1, 1 plus 2, 2 plus 1. Now, the question is, how do we break down the solution to represent 1 plus 1 plus 1, 1 plus 2, etc.? I'm thinking using recursion would be a good idea here. And for every recursive call, we want to see if we can go 1 step and or 2 steps. Since we start with n, we know that when n is equal to 0, we can reach the top of the sequence of steps. So we know that the base case will have to be when n is equal to 0 and it will return 1. We know that if we take 1 step, that will result in f of n minus 1. And if we take 2 steps, that will result in f of n minus 2. Something that we'll have to account for is when n is less than 0, as it means it's an invalid path. We would start with f of 3, then f of 2, f of 1, f of 1, f of 0, f of 0, f of minus 1, f of 0, f of minus 1. Let's start at the root f of 3. We then have to solve for f of 2, then f of 1, then f of 0, which hits the base case so we can return 1. Now we go back to f of 1's recursive call and see that we need to solve for f of minus 1, which is 0, as minus 1 is less than 0. Now we can solve for f of 1 by adding f of 0 and f of minus 1 to get 1. We go up to f of 2 and see that f of 0 still needs to be solved. And if we did the entire recursion, we would eventually end up with 1, as we did with our first f of 0. Again, f of 2 is the sum of f of 1 and f of 0, which is 2. We go up to f of 3 and see that f of 1 needs to be solved, and we know eventually we'd get 1. Now finally, f of 3 can be solved by the sum of f of 2 and f of 1. Since we are branching 2 times at each recursive call, f of n minus 2, which is represented by the right side, we will have a runtime of big O of 2 to the nth power, and space will end up being big O of n, which is the depth of the tree. We know during the walkthrough of this example, we recompute values which can be reduced by using memoization. Instead of recursively solving for f of 0 or f of 1, multiple times, store the value in a memo table, and if it exists, we can just return from there. That will reduce the runtime to big O of n, since we are only doing the computation once per recursive call and the height of the tree can be n. Let's gather our thoughts and create a blueprint. Just a note, I will be doing the blueprint with the recursive solution, as we will code that first and then modify the solution to use memoization. Base cases. If n is less than 0, return 0. If n is equal to 0, return 1. Recursively return f n minus 1 plus f n minus 2. And now it's time to ace that interview and show your rockstar coding skills. you enjoyed the video, show the channel some love. Give it a like or a sub. Don't forget to enjoy a Hot Pocket too. And tune in for the next one.